All right, so today we are going to look at scatterplots. So if you remember in our last lesson, we were talking about bivariate data where we had two lists and we had to, or two variables, and we had to decide which one was the explanatory and which one was the response. Because remember when I said eventually we're going to plot them on the graph, and this is what the scatter plot is, the graph, and this is where we're going to put the explanatory variable there and the response variable there. Okay, so it's crucial at the start that you decide which variable is which, and that's why we practice that, because you'll get a list of data. So we talked about, for an example, remember I said, oh, I could collect all your weights and your height. Now, your weight depends on your height, doesn't it? So weight is probably over here, it's the response, and your height is independent. So, height might be along this axis, the x-axis and the y-axis. Okay, so when you get your two lists of data, you're never going to sort it because that they go together, they're a pair. So if that weight was sitting on one list, then the height next to it is the height for that person. So if you sort it, you'll jumble it up, and that's not what we've got to do. So we always leave the list as they are. And outliers are data points that appear away from the main group. So we're going to get scatterplots. So we'll put our response variable here. And what they'll be is there'll be a little dot for all of them. If you have, and you'll see like that, if we have one out here like that, we might call that an outlier. So we might say, because it's a bit further away. All right, so you just need to comment. You'll say, oh, there's a possible outlier there. All right, so we are going to do the scatter plots on the calculator. So if you have a look here, if I zoom in a bit, we've got our two lists, and we're going to go to the calculator in a minute, and I'm going to show you, but your instructions are there. So we have collected from 10 students, we've obtained an exam the data below shows the marks of 10 students obtained on an examination and the time spent studying for their exam. So what do you think the response variable, which one would be we looking at to see what happens? It would probably be the mark, wouldn't it? You're trying to see what happens there. And down along the bottom will be the time, and that will be the explanatory. So probably the more, don't you think your mark, can you hear the wording? My mark depends on how much study I do. See, if you say the word depends, that's the response one. If you can say a sentence and it sounds like that. All right, so we're going to use these two lists. And as it says right there, you've got to go into listen spreadsheets and pop these two lists in. So we'll go do it on our calculator. Okay, so we've put the two lists in, and we did that in our calculator here. So we had time and mark, and we listed them down in it. Then we clicked the home key there, and we went and pressed the graphs and spreadsheet, the graph page. And then down here is where we clicked for our X list. So we clicked for this one, time was the one we selected there. And then we went and hovered over here and we selected mark. And then we hopefully saw that we got this scatter plot like here that we've got drawn down here. And there you go. All right, so the instructions are there for you. We are going to go practice these now. So the questions are actually in your booklet already. So off you go. Okay, so the other day we've been talking about scatter plots, which were, anyway, let's rehash a bit. So we have got bivariate data, and where we're getting two lists of data from, so two pieces of information from everything that we get. So we get two, which we might call variables. And remember, we put the explanatory variable, which is the independent, which you might know it as, and the response variable here. Now, this is when bivariate data and we do a scatter plot when they're both numerical variables. So say like your weight, it's a number, yeah, and your height's a number, yeah. So remember, we we often did this one. We said weight was here, and we'll put height along there. So then we get these individual dots, and you guys practice that on your calculator, how to get them up on your calculator. So that is called a scatter plot. So now we have to interpret the scatter plot. So how we interpret it is first we say whether it's linear or non-linear. So who knows what does the word linear mean?
Straight.
Yeah, good, a straight line. So see this one I've drawn here, we would probably call that linear. See how the dots are roughly going in a straight line. So you just have to say, and most of yours, nearly all the time, it's going to be linear. If it's not linear, that's probably all you have to say about it, and you just say it's non-linear. What they look like is they might look like this. So can you see where the pattern is going sort of like a curve? Yeah? So that's one where we'd say non-linear. So at the moment, once you get to, if you get one that looks really like that, all you'll have to say is non-linear, and then we're finished with it. We're mainly going to be looking at ones that look like this, the linear ones, all right? So once you said whether it's linear or non-linear, you then say the direction, which means you only have to say whether it's positive or negative. Now, if you remember, if you've got a line going up like that, the gradient is often, what do we call it? Is that a positive gradient? Yeah, we say positive, it's going uphill. So a positive, this one would be a positive direction. If I had another one where the scatter plots were going like that, okay, so I'd call that one linear but negative because it's going down, okay? So that's all you have to say. So when they say, you can even dot point it. You don't have to write any big long sentences. When they say describe it, dot point, linear, dot point, positive or negative, whatever. The next thing is the strength and how strong they are. And what that means is, can you see if you have a scatter plot? So we've got one here, and see how the dots are everywhere. There's no pattern, there's no thing there. So we would say that's like there's no relationship. There's nothing linking those two things together. With this one, can you see that the dots are perfect? Yeah? We would say that's a perfect relationship, a perfect positive because it's going upwards. And these ones, because they're in a perfect line, perfect linear. So then you've got the in-between of these things. So if you have a little look here, so down here on, say this one down here, the dots they're all sort of going in the same direction, going downwards. So I'd probably say it's still probably a linear, so it's still sort of following a straight line, but they're not so all close to being on the same line. So we would say that one is probably a moderate, so it looks like it. And then this one next to it, we might call that a moderate positive. And then over here, can you see how they're getting really close to being on one line there? This last one here, yeah? Getting really close to being on one line. That one's probably a strong positive linear relationship, all right? Now, underneath, can you see this? There's these numbers here, yep? So this is a way that we can calculate this number using our calculator, and it tells us what category to put it in, whether to put it in weak, moderate, or strong. So if you get the R value, and it's called this R value, which we're going to call is the correlation coefficient up here. If you get an R value on your calculator that's +1, that's a perfect positive relationship. If you get an R value that's a -1, it's a perfect negative. So all the numbers are going to be somewhere between -1 and +1, okay? And obviously if you get on 0, 0's no relationship. That's like that one up there. That's what it looks like, okay? So we are going to learn how to find this R value on our calculator. So I'm going to pause it and show you on the computer. Here's the instructions, so I'll come back. When I did this, so this is how you categorize whether it's strong, moderate. Your one is in color. Mine didn't come through on the iPad in color, but I can see in here. I saw it in your book. Where is it? Here. Boys, so you're looking at this. So the color one. So we got before, in our example, we got an R value equaling 0.94. So what category is that one in? It's up here, isn't it? Yeah? Now, the one they did, they got a 0.83. What would that one be? What would 0.83? Strong? What about if I said an R value of negative 0.6? What one would that be? Yep, good. So it's down here, isn't it? It's in between that category. Yeah? So it's a strong model. Yours is in colour, so it's a little bit easier, I reckon, to follow. Okay? So the R value can be positive or it can be negative. If your line is negative, it'll be negative. If your line is positive, it'll be positive. Okay, so